So this next session is, let me pull up the caption, and this is a thing that I'm going to learn from as well. Now, Elena and Softicon, they're based in Poland, so they use in their presentation an AI voice. It is a good one. They're going to talk about ONNX runtime in Delphi. I'll see you after this presentation.
Hello, everybody. We are Softicom, a company specializing in the modernization and migration of software written in old languages. In this video, we are going to demonstrate how to integrate ONNX Runtime into Delphi projects to run object detection models such as YOLOv 8. We will compare different integration approaches, show working examples, and discuss the advantages and limitations of each method. We will be using these tools and technologies. ONNX is a file format for machine learning models. It allows models trained in one framework, like PyTorch, to be used in other environments. It's like a common language for AI models. And ONNX Runtime is an engine for running machine learning models efficiently. It supports many types of models and works on different platforms. We use it because it runs models quickly. It works with models created in different frameworks, like PyTorch or TensorFlow. It's actively supported and used in production by many companies. And other tools that we are going to use are Python 4, Delphi, P4D, a library that lets Delphi run Python code directly inside the application. There are three common ways to integrate ONNX Runtime into a Delphi application. Approach 1, calling an inference service via HTTP. The Delphi application sends HTTP post requests with image data to an external inference service. The service, implemented in Python, C++, or C#, loads the model in ONNX format, performs inference, and returns JSON responses with results. This decoupled architecture offloads computation from the UI and improves performance. What are the pros of this approach? It is the easiest way to integrate without embedding Python, and it is useful for quick proof of concepts. What are the cons? It might show slow performance because starting a new process for every image is expensive, and there is no direct access to inference results in memory. Also, it requires constant access to the internet. Approach 2, direct ONNX Runtime DLL call. In this approach, we connect to the ONNX Runtime directly from Delphi using its C API. The Delphi app loads the ONNX model, prepares input data, runs inference, and processes the results, all through calls to the ONNX Runtime DLL. Everything happens inside Delphi without Python. This is a more complex but powerful option. It gives full control over how the model runs and how the data is handled. What are the advantages? No need for Python. Everything runs natively. Better performance, since there's no process overhead. You control how data is prepared and post-processed. Everything runs on the client side. Your data stays private and there's no need for an internet connection. And disadvantages, more difficult to implement. You need to manage low-level details like memory, data types, and API calls. You must understand how ONNX Runtime works internally. Harder to update or switch models if you need changes later. You don't need Python to use ONNX Runtime. It's enough to download the appropriate DLL for your platform, Windows, Linux, or Mac OS, from the official ONNX website. This DLL provides a C API that can be connected to Delphi. The main challenge lies in data preparation. Before recognition, the image must be pre-processed and converted into a tensor. After the model processes it, the result also needs to be post-processed. Without third-party libraries, these steps can take a significant amount of time. Model interaction is done through function calls to the ONNX runtime. The library is actively being developed and currently includes around 292 functions. Let's have a quick look at how to use ONNX Runtime.dll in your Delphi apps. First, you go to the official ONNX Runtime website and download the ONNX Runtime.dll file for your platform, whether that's Windows, Linux, or Mac OS. Next, in your Delphi project, you import a core function from that DLL. This function, called ORT-GET-API-Base, basically gives you access to the entire ONNX Runtime API. It looks something like this: Delphi function ORT-GET-API-Base, port API-Base, CD-EDCL, external ONNX Runtime, DLL. Once you have that, you call it to get the API interface, which is a struct with pointers to all the functions you'll use. It's like your toolbox for running ONNX models. Then you set up the runtime environment by calling create-env. This basically prepares everything so ONNX can work inside your app. After that, you create a session by calling create-session, where you tell it which ONNX model to use. Before you can run the model, you need to get your input data ready, usually an image, and convert it into a tensor. You do that with create tensor with data as ORT value. Now comes the fun part. You run inference by calling run. This makes ONNX do its magic and give you results. Finally, you take those results, like class IDs, labels, confidence scores, and bounding boxes, from the output tensor. And don't forget to clean up when you're done. Release sessions, allocators, and the environment so you don't leak memory. So basically, by following these steps, you get smooth ONNX model inference right inside Delphi, all through the official C API. No Python involved. Approach 3. Using Delphi wrapper with Python for Delphi. Python for Delphi lets you embed a Python interpreter directly into your Delphi app. You can call Python functions as if they were native and use wrappers like the Softacom YOLO module to simplify things. This approach is flexible and keeps the logic close to the UI, but still requires bundling Python. The pros of this approach are the following. Faster to integrate, no need to write low-level ONNX code. Easier to use Python libraries like NumPy or OpenCV. Keeps control in Delphi. Good for real-world apps with existing logic. And cons, still depends on Python and its environment. Python, pip packages. Requires Python for Delphi and some scripting knowledge. Needs good error handling to avoid crashes at runtime. Environment setup. We've already prepared an environment. To do this, you should have Python ready. Download it from the official website. You see the link on the screen. Choose the 64-bit version for your system. Run the installer and enable Add Python to Path. Then you need to verify Python and PIP. First, open Command Prompt if you're on Windows, or Terminal if you're using Mac OS or Linux. Then check your Python version by running Python --version. After that, upgrade pip by running Python-m pip install -- upgrade pip. And the final step is to install all the required packages. Install NumPy by running pip install numpy. Then install the CPU version of ONNX Runtime with pip install ONNX Runtime. If you want GPU support, there are a couple of options. For DirectML, run pip install ONNX Runtime DirectML. For CUDA, use pip install ONNX Runtime GPU. And finally, install OpenCV with pip install OpenCV Python. Now let us show our Delphi ONNX YOLO wrapper, what it consists of and how it works. In this video, we'll show how our wrapper works based on a test application, the FMX wrapper. We'll walk through its main components. It's very important to have the 64-bit platform set for compilation. It's essentially an FMX application. Technically, you can use VCL too. There's no difference. Just make sure the platform is set to 64-bit, like you see in the video. The setup consists of the test application itself and some resources. The resources are divided into two parts. Python integration and working with the Python code. The first part is Python integration, that is, the Python manager file. Then there's the Python code, which contains the main functions. So the Python code contains the main functions. And then there's the integration of the YOLO model library. This is followed by the main utility code, the types used, constants, and base classes. For example, the detect object, we can show it. It has fields like bounding box, index, class, and level. The next object we use is results. This object contains the data we got, and we can use various events to display the results, or not use them. The core of the program is really just one function, predict. It can be called with different parameters, and we can get the status of the current process, its execution time, and all results are saved in detection wave. Now the example, the actual function call. When creating it, we assign events that will display our results. And here's the function call itself. You can call it without parameters, since everything is already filled in. Then we iterate over the results, which are numbered. This is basically how our app works. If needed, we can select an accelerator, locate the model. We already have it converted to ONNX format. We load the image and can specify the output path where the processed image will be saved. That image will already have the detection results drawn on it. Then we start the actual recognition process. As you can see, it detected a cat and a dog. The output image already has bounding boxes drawn on it. We can add a filter, for example, to show only the cat. In this case, we have only the cat. We can also view model parameters, which is typical for YOLO. You can also generate full Python code. Copy and paste it, or save it as a Python script. It will be a fully functional program. We can see that the output images have been created. That's basically it. Now let's demonstrate how to use object detection functions in a real-world project. We'll show the example using a new VCL or FMX application. The framework doesn't matter in this case. Make sure to select the 64-bit platform since we're working in a 64-bit environment. Next, we'll create a simple interface for the demo. We'll add a panel and place the necessary UI elements on it. First, we add a button to select the model file. And a tedded field where the file path will be displayed. We'll add similar controls for loading an image. To make the code cleaner, we'll rename these components appropriately. Then we'll add dialog boxes. For the model file, we use a standard file dialog. And for images, token picture dialog. We define event handlers for the buttons. After a file is selected, its name appears in the corresponding tEdit field. The same logic applies to the image controls. Next, we add a tMemo component to display the results. We place it on the form and clear its lines. Now let's add a button to trigger the object detection process. We'll name it inference and assign an event handler. To use the ONNX RTD wrapper singleton, we need to include the ONNX RT.core module. The inference is performed using the ONNX wrapper.predict method. It can be called without parameters, if they're already defined, or with parameters. In our case, we'll specify both the model file path and the image path. Once the inference is complete, we access the results from ONNX wrapper.detection results. We extract each result and output it to the T-memo. First, we display the class index. Then the class label. After that, the confidence score and finally the bounding box coordinates. We format the coordinates as comma-separated values, left, top, then right, bottom. At this point, the app is ready to run. We compile it, load the pre-trained model, and choose an image. Click Inference, and we get the results. We see that a cat and a dog were detected in the image. Now let's improve the visual part of the app. We add a T-image component to display the image with proper scaling and aspect ratio. We update the code so that the loaded image appears in T-image. After inference, we can also get an output image with detected objects drawn on it. We define the name of the temporary output file in the constant section, pass it as the third parameter to the inference function, and display it in T-image once processing is complete. Let's run the app again. Select the model, load the image, switch to full screen, and start the detection. Now the recognition process is fully visual. And again, we see the same cat and dog. You can explore other features of ONNX RT Wrapper using the demo app included with the library. Integrating ONNX Runtime into Delphi applications opens the door to using modern AI models directly in native Windows apps. The choice of approach depends on the project requirements. For quick prototyping, communicating with an inference service over HTTP is often the simplest and most efficient solution. For maximum performance and no external dependencies, direct ONNX Runtime API calls are best. For rapid integration with flexibility, using Python 4, Delphi, and wrappers like the Softicom YOLO module offers a good balance. That was all from us. Thank you for your attention.
What a great presentation. I actually really enjoyed that. And a few people said the same thing as well. Where was it? Yeah, Milan. He did point out, by the way, at the end of it, that he meant bravo, not brave. It was brave. But so Softacom, as I said, they're based in Poland, and a good proportion of their people don't speak English, and some of the ones that do speak English speak it with an accent. So they were very concerned about being understood, and so that's why they use the AI voice. But you know what? I agree with Milan. It actually really worked. It worked very well, and I think the way they paused and they showed the code, that was great. I mean, it was weird to hear people say Delphi again because you've all got used to me saying Delphi the old way, the European way of saying it. And Marco says Delphi as well because he's from Italy. But what a great, top marks there, Softacom. And Serge is the boss there. But where's the QR code? But these are the guys that did that video. Softacom, great company. They're technical partners. They do conversions and they Delphi programs for hire and all the rest of it. Good bunch of people, very reliable. I'm big fans of them. They use the ONNX runtime, which, as you saw, you can call and does a lot of stuff locally, which is a very useful way of doing things. And as Fabio says, it was a really good pace. Yeah, it was perfect. When I first heard them say, "Oh, is it okay if we used like AI generated voice?" I thought, okay, it might be one of those videos where they talk, but no, it was absolutely, it was one of the best videos I've seen for a while. And you can't hear me clapping because of the noise cancellation, but good job, Softacom, on that. I really liked that. That was a great video. They also talked about Python for Delphi. If you scan that, you'll go to Python for Delphi. It's a free download, and you can embed Python code in your Delphi apps. But there are also there's a Delphi FMX and Delphi VCL, which are Python libraries that allow you to create FMX and VCL apps for GUI apps for Python. So you can have a Python app that's using FMX and VCL. So it's quite a whole rounded solution. And the other thing, of course, is Rad Studio, which is the main core product that we use. But I thought it was great. I think it was a good job. Callum says, nice. The model I am producing is currently in Python, and soon I'll be looking to integrate it into our Delphi program. Today is very useful. Yeah, well, I can safely say if you go there, I think I've got this pointed to a thing like getting started with Python for Delphi on our blog site, but it does have the links. They're free downloads and they're open source, I think. We also sponsor PyScripter, which is a really good Python IDE as well, and Kyriakos works on that. But Python and us, we're kind of like this. They fulfill different purposes. Python scripting, very powerful in AI, very popular in AI, and the Delphi then adds that kind of security wrapper and power and convenience as well. So great stuff, and integrate it into your Delphi program. You can do that today. Python for Delphi has been around for several years now, at least 3 that I can think of, maybe longer. So it's there and you can do it. But if you want a Python app and you want some AI and you find it easier to do Python, then that's the place to go to. That blog post will point you to all the resources and tell you how to get started as well. So good job. And like I say, once again, thank you to Softacom for that presentation. And also thank you for them introducing us to ONNX Runtime. It's been a heck of a day for us, yeah, and I think it has been a good day.